Alright, so in the past couple of weeks I've noticed a couple of things. I've noticed that I can actually make videos with this tablet software that I have, and I've also noticed that I can sign up for a YouTube account and post those videos online. So what I'm going to try to do in this video is work out all these warm-ups for this week, the week of December 5th. I'll explain the steps along the way. I might be a little fast with certain things, so if something doesn't make sense, the beauty of videos, you can always go back and rewind it. So that if I say something too fast or maybe unintelligible, as I'm well known for being, you can always go back and pause, of course. And I suggest pausing, or you can even pause the video and try to work the problem out by yourself. Once I do the solution, you can see if you did it correctly, where you made your mistake, if you chose the trick answer, since on the SAT and ACT tests there's always these trick answers that they want you to pick. Anyway, let's get on with it. Number 1, it says if x squared plus 6 equals 10, then x equals what? You'll notice this is a quadratic equation because it has x squared as the highest power. However, it's not a complicated one to solve since we don't have a linear term. All we have is a bunch of numbers and an x squared. So our goal is then to isolate the x squared so that we can solve it by simply taking the square root. 6 is being added, so let's cancel that out, both sides. Remember the golden rules, whatever you do to one side of an equation, you have to do to the other. So 10 minus 6, those are like terms, so I can combine them. 10 minus 6 is, of course, 4. The problem boils down to x squared equals 4, so to solve that, all we need to do is take the square root of both sides. The square root of x squared is just x, and the square root of 4 is positive or negative 2. If you try to put that in a calculator, it's just going to say positive 2. We have to remember that when we take square roots when we're solving equations, we have to include both a positive result and a negative result. You'll see why in a second. So our answer is x has to equal positive 2, negative 2, so D would be correct, but A and B are both solutions. And we could actually test these out if we wanted to. I mean, we could just test these numbers. And this is an important part of equation solving. Is once you get the answer, you're not fully sure if you're done, and so you test them out. When you solve an equation, you're making a claim. I'm claiming x has to be either positive 2 or negative 2. So let's see. If I plugged in a positive 2 wherever I see an x, positive 2 squared plus 6, 2 squared is just 4, that's 2 times 2, plus 6 gives me 10. And that is the exact equation. It works. It fits in. We check the solution, so it must be correct. If you try the same thing with negative 2, you'll find out that negative 2 times negative 2, or negative 2 times itself, that's squaring, is still positive 4. Add 6 and you get 10. So they do both work. The 0 does not work. If you tried 0, you would get a statement like 6 equals 10, and that would be false. So 0 cannot be a solution. What you're going to find out later on is it's actually impossible for a quadratic equation, that's something that has x raised to the second power, it's the highest power. It's actually impossible for that to have 3 solutions. So E is actually impossible. And that's due to what's called the fundamental theorem of algebra. If you don't know what it is yet, we might discuss it later on in class. Number 2 says, which expression best describes the area of the rectangle pictured below in terms of x? It does say note, figures not drawn to scale. That is important to know. What that says, what it means in plain English, is that the proportions, the dimensions in this are not accurate. They're not accurately described. This side is not that much longer than that side. So remember that for a rectangle, area is just length times width. And to be honest, it doesn't matter which side you call the length and which you call the width. So we have to multiply these two things together. 2x times quantity, 3x plus 2. Now whenever you see a monomial, that's a single term, times some set of parentheses, which has more than one term, we know that we have to distribute to get the correct answer. 2x times 3x gives me 6x squared, and then 2x times 2 is just 4x, positive 4. Now the positive I just put as a plus sign, so the answer is A. That is, it's actually a function. You could say this is a function of x, which gives the area given any value for x.